So now second is Gerrit Schramm from Airbus, and yeah, he will tell about Apollo in SysML v2, a mission for the open source community. So Gerrit, the floor is yours.
Okay, so also warm welcome from my side here. My name is Gerrit. I'm from Hamburg, Germany, Earth Milky Way. Maybe this matters during this talk. But Apollo 11 seems to be something like from the past, but I will not give you a history lesson here. I will talk not about the past, I will talk about the future, and specific the future of systems engineering. Yeah, what should I say? Houston, we have a model. So at Airbus, we have been also diving into SysML v2, and we figured out some things that are of our interest. So first of all, we figured out MBSE as a former alternative to traditional document-based approaches. This is pretty obvious, and I think within this audience, I do not need to emphasize much more on this. Same for SysML v2 formal syntax. This yields a potential of improved precision, as my previous as a previous presenter also told you. But what we were lacking is we were looking at the learning material, and we were looking at available examples, and we haven't found something like a non-trivial case study. And yeah, of course, within our company, we do have those non-trivial case studies, but it's intellectual property reasons that do not allow us to share those non-trivial case studies. So then we thought it might be a good idea to go for this iconic Apollo 11 mission. It's there's a lot of public domain knowledge about this, and yeah, we chose this for the modeling. And what we also wanted to have is some kind of a benchmark. Yeah? So if you're a tool vendor, a SysML v2 tool vendor, there are plenty of them on the market right now. We see them emerging. Yeah, we as a big company wanted to have some kind of a benchmark so that we encode the problems that we face with SysML v2 approaches into this Apollo model. And yeah, the tools can then load the model, and you see where the issues are, and if they are able to handle everything of the model. Yeah, so, and of course, we are somehow known as a vendor for complex systems, and so we need something more complex. What do you find in the model? Yeah, so the key models, the key things that are in the model are, first of all, it's a fully textual notation. So you will find it on GitHub, and it should be compatible with the model as code paradigm. And we are also using very vastly the advanced specialization that ships with SysML v2. See some examples here already mentioned. And for, let's say, all the attributes and properties within the model, we were sticking to the ISO 80,000 standard, and that should us help improve the ambiguity of the shown attributes inside. What you would also find inside the model are the timeline modelings. In specific, there are time slices and snapshots that represent the model at certain states. So then, without further ado, let's dive into the model. And yeah, since it's quite complex, it might make sense to find some kind of an easy entry point. And for me, one of the let's say straightforward entry points is the mission itself. Yeah. So what do you see here? We see the Apollo 11 mission, which is a manned space mission, and it consists of the Apollo 11 mission system. It has a crew, which are represented here as actual individuals, and it performs the lunar space mission. You will not see a closing bracket here on the side because there's much more stuff to look at, and I just figured out some of them to make it a bit easier to consume here. But what actually is the Apollo 11 mission system? We can have a look at this as well. So it is a system of systems, as you see on top, and it consists of an individual, which is the SA506, so the actual serial number of the launch vehicle that flew the actual mission. Yeah. You also find something like a spacecraft, which is an Apollo spacecraft, which of itself is a constituent system, which consists of the command service module 107 and the lunar module 5. So you'll find all the individuals, not only exclusively of the Apollo mission, but of all missions within the Apollo program here. Let's go to the next slide. Let's see some actual footage here from the system itself. So the Apollo spacecraft on its own is a system, and it's a spacecraft. It's pretty obvious, but it's encoded in a very direct way here, and it consists of the escape launch system, which you see on the left picture here, also of the lunar module, which you see there on the right, and the command service module on the bottom right in the picture. And also you see the docking interfaces between all those stages of the rocket, which are modeled here as an interface. So when we come back to the Apollo 11 mission system, we can also have a deeper look at the actual launch vehicle, in this case the SA506, where you see it is a Saturn V rocket, and you also see the other rockets from the other mission, as already promised earlier during this presentation. So you could also ask this thing, what actually is a Saturn V rocket? Yeah, well, it has some kind of a height, it has a launch mass. Yeah? Here you see the usage of the ISO 80,000 standard that's fully compatible with SysML v2, which is, by the way, very awesome. And you see the actual 3 stages here being composed in the way you see it here. So both as a part, but also all stages together as an ordered set. And again, the interfaces between the stages. So this is, let's say, one possible entry point of the model, but there is more. So when you are using MBSE, you're not talking about only the language, within this case is SysML v2. There should also be some kind of a tool, which I will not talk about today. But there's also a methodology. And the methodology we used is what we call the modeling framework CoSMA. And it is a structured approach. And I will not dig into the very details of this framework, but I will give you a glimpse of what it actually is. And the CoSMA approach is like a 5-layer architecture framework that decomposes the systems into interconnected layer of concern. And the first layer is the purpose layer. Yeah? This answers the question why the system actually exists. And within this layer of our model, you will find entities, for example, the NASA. You will also find requirements like astronaut safety, and you will also find capabilities like a heavy lift launch on the very high level. And of course, you can dive deeper into the details, but these are the most prominent ones. Then the second layer is an operational layer, and in which is described when things happened and in what sequence. And here you find the Apollo 11 mission, which I have shown you some details of in the very first slide of SysML v2 code. Then there is a functional layer, and this shows you what the system needs to do. And 2 examples here are, for example, perform the lunar mission. We have seen this, but also like provide the stage 1 thrust to the entire rocket. Then we have a logical layer. So you see it's some kind of an FLT approach here. The logical layer shows the abstract parts, and here you find concepts like, for example, the launch system. And in the technical layer on the bottom, you will find concepts like hardware components, masked components. You also find the Apollo command service modules and all the individuals. So some of you might have become curious how to get the model and how to play around with it. And I'll come to this in the next slide. But before I will show you how to get the model, I tell you something about the license. So we have licensed this thing under the MPL2 license, which allows you to mix the license with your own code. So you can use this model to extend it, or you can use the model to integrate it as an example in your tool. You can also use it commercially. You can modify it, you can distribute it, and you can use it privately. What you have to do is you have to include the original copyright notice if you do so. Yeah, so you cannot change the license on the MPL license files. And what you cannot do, you cannot hold us liable for damages, and we will not give you warranties of our code. So the golden rule is, if you modify something, you have to distribute it under the same license. So where do you get it? You get it here. It's on GitHub. Go to github.com/airbus/Apollo11 SysML v2, and this is where you find it. What you would also find if you go to ResearchGate, we have a preprint paper explaining you much more details of this model, including the CoSMA framework. And we're really happy to share it. We are really happy to discuss with you. And yeah, I think I made it on time. I have a slide for Q&A, if there are any. If not, drop them in the chat so we can answer them offline. And yeah, final words. Start the repo, fork the code, and make pull requests. Thank you, everyone.